Peter just suggested I should do my own introduction, but that's something I really didn't want to do. So either Anita comes back, or she does it afterwards, or we just skip that part. 30 years of tuck. It's a long time, and I've been around for most part of it, actually. So what I was trying to do and doing now is giving a personal kind of history of a part of it, LaTeX development, and so what I'm running you through is kind of a retrospective of what I think is has been important over the years, 2 decades, and then we will see. So we don't have much time, but I just learned we have a little bit more, but probably not that much. Here's a kind of legend of what I marked on the slides. Milestones that I think have been important, that sums up. And if they were really sort of long-lasting events, I also mark them yellow. That's all biased, obviously, and afterwards you can't beat me for it. Then there are things which I also think are really, really important, but they had no effect whatsoever. Different reasons, wrong time, wrong way to present them, maybe misconception on my part, I don't know. But those are the ones with thumbs down. And then I have downhill slide. That's kind of when things went bad in one way or the other. And that's what I'm going to in the round from the late 80s to now. Okay, so late 80s. I got in contact with tech through the tech book and AMS tech on a Multics machine. A page was about this size because we didn't have the right printers. So essentially I saw the program, but I couldn't use it. And then sometime later I got a PC Tech version with the LaTeX manual, LaTeX 208. And I thought, great, this is kind of the way things should go. This has sort of potential. And I fired it up, and it died. And it died because memory was 512K, and LaTeX sort of in the middle of loading article said, okay, goodbye. That's it. So I had this manual, I couldn't use it, and what I did was I wrote my own first big tech program, which was kind of a mini LaTeX. And one of the things that I learned there is to program very, very concise. And that was something that was fairly useful in the years after. And now sort of the first, I think, very important thing that happened was I picked up the literate programming ideas from Don and thought that should be something I should use for my own programs, my own tech packages, and developed doc for that. It's not really perfect, it's rather bad actually, but it was sort of the best I could do. And the important bit about it is nowadays we actually have about 85% of all the LaTeX code that is on CTOM is actually in that format. So we have a very firm standard these days. And also in the 80s I started to build the first array, multi-call theorem and other packages, and published first time in Tugboat. And the most important part about that was for multi-call I got the Donald Knuth Scholarship. I don't think it was really sort of the best thing around at that point in time, but it was a really, really big chance for me, because that was the only way for me to actually talk to the big guys personally. I mean, I had buggered Leslie with emails over time, but that was the chance to come to Stanford on a very, very important date, namely when Don was deciding or about to decide what to do with tech. And I could go there and stay in front of the crowd and actually gave a talk about, well, LaTeX is all rubbish. It was kind of a bold thing to do then. But I mean, late 80s, I was young. So I came up and said, oh, this is not working and this is not good. And I gave a long list. I mean, this is basically, TeX was good for math. LaTeX was bad for math. It just had rubbish interfaces and couldn't do anything. You could use any font as long as it was computer modern. In 2 sizes at least, or 3. So that was better than plain text, but okay. Graphics, color, no interfaces. If you use color or graphics, then definitely the thing wouldn't work on Nextdoor. And if you were European, or at least not English speaking, then you had this little problem of these dots and other fancy character bits that just didn't work quite well. I mean, you couldn't hyphenate and all these kind of things. And yeah, there are a couple of others. We come to that later. The other very important part was that we were, that's interesting. I still have 29 minutes. That's probably a lie. Let's keep it up from here. That's a good way, isn't it? Okay, so go on. The other very, very important point on the Stanford conference was that we worked together with Don. There was an open session where we discussed stuff. There was discussion before and after, where we tried to talk him into various bits of changes. And the good thing about the TeX 3 was that it actually provided an extension to TeX that enabled it to be used outside the English-speaking world. The bad part of it, it actually, I would say, didn't went far enough in many respects. And basically, since then, there was a freeze completely. I mean, there are a couple of things that happened on the engine side, but the reason that the way Don announced that's the end of the story made a big impact there. I should make that red actually, but it's not on LaTeX, so that's why it isn't red. Okay, and the other thing was that after the conference we had more discussions with Leslie, and I spoke with him over a couple of sessions in private, and by the end of it he basically signed over LaTeX development and maintenance to me and Chris and Rainer, and that was kind of a very big change for how it went further. I mean, it would have been gone completely different if it wouldn't be sort of our faults to shape the history from there on. So then we come to the 90s, basically, running full speed, you could say. There's Babel development. Johannes is here. I mean, he's instrumental in getting sort of all the various Western languages into the realm of LaTeX. Rainer and I did the new font selection scheme development. And then in 1990, I have the first one down, in my opinion. I gave a talk in Texas, I think, and on guidelines for future TeX extension, and I think it was actually quite a good one. Or maybe not the talk, but the paper. And what I got for it was basically a lot of heat. Something like, you shall not doubt that TeX is the best program in the world. And yes, was kind of really religious at that time, which wasn't what I was doubting anyway. But okay, so it didn't have an impact other than yeah, being translated in a couple of languages and sitting around for a long time. And then we came. I mean, this all happened in the same kind of small time frame. We came to this place 18 years ago. I don't know how many of you have been here, a couple. And we met in some remote hall. I can't remember where. I'm not sure I would find it. But there was this guy from Canada coming by bicycle. He was very instrumental. Remember that? Yes. And what we came up with was the Cork font encoding. So that was an attempt, and I would say a fairly successful one, to actually go away from 7-bit fonts to 8-bit fonts, which was a huge step forward because it enabled to use TeX with a lot of languages. Even through that TeX 3 had the languages, hyphenation and everything was still a problem because we didn't have those sort of standards in the fonts. And coming up with the standard was really, really important. Actually, it was this and this because we went overboard. We tried to squeeze too much into it, and that made up for a large number of, or large is wrong, some bad design decisions, which then afterwards haunted us. Like Don did with making the $ and the pound sign being the same slot. And if you change fonts, your bills got up or down in value, depending on the economy and depending on something else. But it was not a good choice by him, and we made similar mistakes. But anyway, it was a very big step forward, and the 8-bit fonts have been instrumental for TeX for a long time. Now we are sort of on the rise of making that less important, but it's still there and it's still important. But using fonts was not just done by a new font selection scheme that gave us a model and the font encodings. We also had to have a way of getting PostScript fonts and stuff like this into the TeX metrics. And there an important step was Alan's font ins program that more or less did this automatically within TeX programmed as a TeX program. Okay, another thing also in the 90s, Rainer and I got a commission from the AMS to take AMS TeX and turn it into something that could be used with LaTeX. And then about 1993, we released LaTeX 2E as a beta version, and then a little later in June 1994, it got officially released. So what we did between 1993 and 1994 was fixing a number of things. Input encodings were added at that time, and I think some other stuff. So what's the status now? Actually, LaTeX 2E resolved a lot of the problems that I sort of boldly said were all wrong. We had mass support, we have language support, we had a different font model, we had, I think, quite a decent graphics interface that abstracted from the underlying stuff as best as we could. We had for some extension interface for packages, so they weren't competing arbitrarily with each other in order. I mean, they still do, and it's still a hassle. But the option model and use packages and so on, that actually gave a sort of step forward. And yeah, and what is remaining? That's the hard bits, I would say. No consistent internal programming language. No really high-level interfaces. And a fairly simple-minded page model. Yes, but everything else was there. And so we struggled on looking for the other bits. What also happened in the early 90s was we were trying to do mass font encoding, similar to what we did for Cork. Gutenberg organization sponsored a student for 3 months to work with the LaTeX project, and he came up with, I think, a very, very good sort of analysis and proposal, and that's it. And I think Barbara now, with the Stix fonts, I don't know, 10 years later or even later, finally could use a little bit of it. So in other words, it was the wrong time. Nobody was really interested in that work. So yeah, that brings me to the first consolidation phase. And I marked this doggy book yellow as a very long-lasting effect on myself. But not so much because it sold well and got translated in a couple of languages, but by chance it became, or it made a big impact in terms of standardization for the LaTeX environment. It wasn't intended this way. I mean, it was. The original idea, I think, was let's document what is available in CERN and have this nicely packaged so that LaTeX user could use it. But what it turned out to be in the end was more or less, this is what should be available in a LaTeX distribution. Unfortunately, most of the stuff we documented from CERN was not too bad, so it was actually having the right kind of effect, but it was really by chance. Okay, graphics companion as a sideshow, also a lot of work, but not so much impact. And that brings us to the second half of the 90s, and the second half was what I would call sort of mainstream. We were trying to run the show sort of as a product, because that's important if you want to have a large user base served. So we had regular maintenance so that everybody sort of could stay on the same level. We developed, actually that was early 90s, I think already, sort of a regression test suite that automatically was taking changes and checking them against defined outputs so that we knew something would break. If we change here, it breaks there. And it happened often enough. I mean, nowadays it's all normal. Agile programming, test-driven development, whatever. But we did it in the early 90s, and then in the late 90s we actually sort of automated a lot of that. The first downhill slide, because we had to work with EMTech distributions and all this kind of stuff that were running on very small computers, we did a lot of hacks to get things small, and that was now sort of starting to haunt. But that's the way it is. I mean, otherwise we couldn't have reached those users. We even had a LaTeX version, I don't know if anybody remembers. You could compile the LaTeX format in 2 versions, and one would largely take a lot of the code out of the kernel and only load it if you ever needed it. So the kernel would be even smaller for it. We finally, I think around 2000, decided we are not going to support that any longer. But I'm sure there are still EMTech distributions out there somewhere. Anyway, trying to tackle the remaining problems was something we did as well. Already in 1992, we wrote a complete kernel in what we later called the XPL3 language. But we never published it, and we only published XPL3 or part of it in around 1995 or 6, and that was really sort of wrong time and not very well done. And the result was basically we missed that opportunity to actually make an impact there. Also, it wasn't that stable at the time. It was more like, look at here, let's discuss this, and okay. Same was the development of the design interface. I think came out very well, but because it was based on the stuff that wasn't going to be used at this point in time, it wasn't going to be used either. We didn't have a critical mass of users trying around with it. But one more important bit, I would say, we were trying to sort of solve some of the license issues around the tech world by coming up with our own sort of standard license, like LPPL. And well, this brings us into 2000. Project decline, yeah. I worked on a new output model, got it, I think, fairly wide, well down the road, but it wasn't finished. So, and it wasn't finished, and then I basically sort of stopped working on LaTeX and anything for a number of years for personal reasons. So that all sort of hang in the air. I came back when the fight about LaTeX is not free software started, Debian. It took me about 1,600 email messages to get it, and you remember that, right? To get people convinced that LaTeX might be free software, even though it predates free software in some sense. It's older than a lot of those terms. Some interesting figures, actually. Nowadays, we have about 50% of the licenses on CTAN being LPPL, and given that not everything is LaTeX, that's not too bad. And the important bit is that that LPPL is trying to solve the maintenance problem. People go away, and nobody could use it if you use a strict kind of tech idea, don't touch me unless it's me, or rename it. Anyway, another downhill slide. Maintenance got more and more rigid. Here's a bug. Oh, thank you. We put it in the next release. Half a year, 1.5 years, 2 years. Didn't really work for something like there's a typo in Babel, or you did earlier releases, but something like VarioRef was badly affected from this. Okay, second interlude. Peter Gordon asked me, could you redo the LaTeX companion together with Michael and Michelle, sorry. And yeah, we foolishly tried to do that. And so I was to some extent surprised coming back more to the LaTeX world to see how much actually evolved in the last years, and it was an enormous amount of effort to sort of try to capture the state of art, if you like. Basically, that was a complete new book, 90% of the old rewritten, about 100% added on top. And the important bit is, again, that I think it fairly sort of broadly covers what is currently sort of around. I mean, obviously biased decisions of what we describe and what we leave out, because there are many packages in parallel that would be equally good. But the important bit is it gave sort of a nice, concise picture of what is there at this point. And that brings me to now. What's the status? Remaining LaTeX shortcomings. Well, I had listed 3 before. To some extent, the situation has slightly changed. This Expel language is now really sort of stable and usable, thanks to largely Morten. We have those high-level interfaces, and they could serve as a basis to actually produce sort of a consistent designer interface. And people also within the 2E world have built interfaces like geometry, talk handling, and so on and so forth, which could be leveraged and standard. The thing that isn't so good is a complex page model. The extended output routine is, I think, a very fascinating beast, but it's still not production ready and would take more time. But anyway, first of all, a large part of the problems in the output routine and other parts is really due to the underlying engine. I mean, it's a Turing model, fine, but not everything you can program doesn't mean you can program it in a way that it is production usable. So we have these limitations that make a problem for some of these problems. And then the other question is, do we can reach a critical mass of users to switch to something new? Because if you have a problem and you want me to solve it, and you have a problem, but those problems don't sort of overlap, then solving both problems may say, for you, I don't want this rubbish over there. It's changing my input, or it's changing something, so I'm not going to change. We had the same problem with LaTeX 2E, really, because in the Americas, people were thinking, why all this font shit? Sorry. We don't have those characters. Why do I need to install all these new fonts and metrics? I'm not going to change. And effectively, there are still 209 implementations out there in the Americas, largely. Anyway, so is it dead? I have 3 answers for you.
Yes, no, maybe.
Picture is not very good, sorry for that. But actually, it's a very small reef shark, and he would not kill me. So probably this is not true. Alternative answer. It's fairly fragile. That's more like it, actually. And I have a third one. That's a nice tree, really. Yeah, I think largely it's between 2 and 3. And the question is, what to do? How do you go from there? So, how many seconds do I have left? Not according to my watch on the left. I'm sorry for that. Big points. What really happened over those 2 decades was we had really big issues and pressing problems, and those got largely solved. There were a lot of consolidation efforts, and those were important to make Leslie's prediction wrong, because he said to Chris, by 2000, I think, LaTeX and tech and everything is gone. But actually,
5 years.
yeah, but actually, it was thriving. I mean, it was actually getting more people because it was a usable product and basically standard distribution. That's an important part I didn't mention. I mean, I could talk probably a whole day about this kind of history if I would start in all the other strands. This is really focused on one part. Anyway, and then for good or worse, people like Chris and me, we were responsible for being fairly conservative and telling you, sorry, we're not going to change the LaTeX article style, even if it is probably horrible as a design. But there are millions of documents out there that expect to look the way they look, and it's no point, the wrong solution to sort of change that and improve that. Make a new class, make a new article for whatever journal you want to do. Okay, so that's sort of the big points there. I could have come up with more, some conclusions. Team size. Well, you can challenge that, but basically everything that I've seen work well in the tech world was an effort of 1 person, 2, 3 people, very small teams. Any kind of committee approach that was tried failed. Typical developer profile, yeah, largely students, academics, and then a couple of dinosaurs like me, still hanging around and doing stuff. But the problem is, this is good if you want to develop something. It's rather bad if you want to maintain it for a large community. And we have seen that with packages hanging around in CTAG. Nobody was able to change them because the license said, don't change me. And nobody was around to actually do this. One of the reasons why we came up with this maintenance idea in LPPL. And then there's this big dilemma, what I would say the big dilemma of tech or LaTeX. LaTeX is not just a typesetting system. It's an exchange protocol. People expect that if I write an article and send it to you, it will look at your end exactly like the one that I've written. And if I submit a paper to a journal, I don't want to have it come out a page longer than the journal accepts. When I made it 8 pages long, it should be 8 pages at their end. And this kind of collaboration basis is sort of against rapid development, and you have to solve this kind of conflict. I mean, it would be like if a C compiler would not just be improved to make faster C code, but every once in a while the people would start changing the language in the compiler and expecting this kind of being distributable. The reason that you can do this is because the C language essentially is stable. Okay, C is not a very good example for that. You had to add those preprocessors and everything to make it then sort of look like. But what I'm trying to get at is the language itself was stable. In LaTeX terms, everybody thinks he can change, or a lot of people think they can change and twiddle the packages direct on their installation. That's fine for themselves, but if they want to run on a large scale with collaboration, it wouldn't work. Okay, another conclusion. Whenever you try to do this with change, there's always the question, is it sexy enough for your users? Because if you don't get those users to change quickly and with a large enough proportion, then you will fail. And as I said, with 2E, it was touch and go. Even though I think we had a lot of sexy features in it, it wasn't really sexy enough for everybody. Another, I think, important part, clusters of activity. LaTeX development peak was around early 90s. If I sort of look around, there have been, over time, a number of failed attempts to work on the underlying core engine. I mean, some improvements, some changes. Nowadays, we use eTeX or PDF eTeX as a basis. So there has been some work. But sort of the real big stuff, actually going after the original model and maybe coming up with something completely different, really didn't take off. Maybe that's the time now. I don't know. Yeah, and coming back to LaTeX, for LaTeX to evolve. As I said, I mean, there are these big open problems, but are they big enough for the user base? That's really the question, whether you could identify that. The other question is, some of those big problems, can they be solved? And that brings me back to the question that the underlying tech engine has restrictions. And assuming you can, and you come up with a new program with everything around it, then you have to get the existing base, which is, I would define something like the amount of packages that are in the LaTeX companion these days. Not necessarily the packages themselves, but sort of the topics. And you have to provide that day one to actually get people potentially go over. And that would mean a lot of work, manual labor, and probably money to make so. And you're not even sure that it will work. Yeah, and then there's this one last thing. LaTeX did that in the end of the 80s. Perhaps it's time for me to do that as well. And with that, I would like to thank you. Sorry?
Some time for some questions.
Yeah, and your introduction, of course.
I know. I'm so sorry. I'm not really feeling that well, so.
Oh.
Yeah, Frank decided to take on a new career as an exotic dancer. And
Tai Chi, actually.
yeah, exactly. Does anybody have any questions? We have time. No? Yes?
John.
Do you think it's possible to replace the underlying engine and still have LaTeX completely compatible? Or son of LaTeX or daughter of LaTeX, whatever it might be called?
With gradual stuff, extensions, yes. If you really go for a kind of different model that would involve the underlying macro language to such a degree that I would say no. On the top level, to some extent maybe, but I think you would need to find a new user base. You wouldn't take old timers to change. So if you have a new, if you would be able to attract a new user base, then yes. It could look sort of similar on top level, but there will be too many changes internally that I would think you wouldn't get people that are using LaTeX for years or tech for years to change.
And now that the continuation of this is this doomed tech and LaTeX?
This is what I meant with this last picture of the tree. It is fairly robust right now. It has a certain amount of decline because we get more people getting older not using it and less people younger coming to use it. But if you would sort of radically change, you might kill it faster. You might not. It would mean very, very careful planning. So it's not sort of something that I would believe could happen sort of spontaneously at this stage. You wanted to ask something? Yeah, Boris?
Speaking of upgrade path, I have two related questions. First question, how much bad design decision in LaTeX 2E was forced by the compatibility with 2.09? And the related question, how much bad design decision is going to be forced on you by the compatibility with 2E on the LaTeX 3?
Well,
can you please repeat the question?
yeah, the question was how many bad design decisions have been introduced or being forced on us because of compatibility requirements in 2E, and how many sort of, the following question would be introduced on trying to do compatibility in a follow-up. What I said for the follow-up is that I don't believe you can get further. We solved a lot of problems, and the remaining hard problems would require so much surgery that compatibility in the sense of in the way we tried it with 2E would not be possible when you go further. So yes, we made design decisions, or we kept things working the way they worked just for compatibility, and some of that would have been better scrapped at the time. But I don't think, as far as the problems we tried to resolve, this wasn't really so much an issue, because we really worked on the sort of more localized bits, and the changing the grand scheme was just not possible. So if you say it was a bad design decision not to go and scratch it all and start fresh. But Chris, you want to say something different?
I think my answer to that wouldn't be a real answer. It would be that the constraints of various aspects of tech were so much bigger a thing than any compatibility constraints.
Yeah. But this is what I meant. If you want to go over those constraints, you would need to change the underlying whole model. And then, once you have changed that, compatibility could be only by sort of introducing some external sort of translation kind of mechanism that takes old document, but not something like we tried in 2E, that 209 documents, except for very specific cases, would actually still run. Any other questions? Okay, then I thank you. One question, Barbara. I think that's my oldest T-shirt. Do you know how old that is? Speaking of tuck, boat and stuff. Do you know that? Anybody knows? It's the old tugboat that was on the front after a certain period of time. No, early on, and then later came the press, right? Anyway, so this is younger, but I think that was the most exotic one that we ever had, didn't we?